On 8th of October, this year's Nobel Prize in Physics was awarded to John Hopfield and Geoffrey Hinton for their research in AI. Now there are many interesting questions and we will try to answer them in this video. We'll learn about the artificial neural networks, the Hopfield Network, the Boltzmann Machine, and discuss how AI has transformed our world. Can we achieve AGI, that is Artificial General Intelligence? If we do, how could it change everything? And finally, we will talk about the dangers of AI if it becomes more intelligent than humans. But before we jump into this complex topic, let's first understand what is artificial neural network. So let's start with an example. Think about your brain. It is made up of billions of neurons. Now most of us don't use it efficiently, but when we do, we are able to think, learn, and remember. This ability makes us an OP in the animal kingdom. With this intelligence, we are able to solve complex problems. We are able to build complex structures and do many wonderful things. And as humans developed from hunter-gatherers to whatever we are today, we started exploring complex questions in physics, chemistry, biology, space, and we realized that however intelligent we are, there are limits to our intelligence. There are complex problems. We needed something that could process huge amounts of data and solve complex equations. A tool that could match the speed and the complexity of problems that we had. Therefore, there was a need of artificial neural networks. A tool that could think like humans but without human limits. Artificial neural networks mirror the structure and the function of neurons in human brains. They are made up of many small units called artificial neurons. These neurons are connected to each other and organized into layers. Each layer has its job. The first layer is called the input layer and the raw data is fed to it. Next, the data moves through one or more hidden layers. These layers process the information by performing calculations and making decisions based on patterns. As it moves through these layers, the network learns from the information. Finally, the output layer gives the result. The more the network is used, it gets better at making accurate decisions because it adjusts the strength of connections between neurons. This process of improving is called learning. Now, these networks are not programmed with the specific instructions like traditional softwares. This means it does not need step-by-step instructions. You can simply show thousands of examples of something. Let's say here pictures of cats. If you feed the data of cats to the machine, it slowly starts recognizing the features that makes a cat, and over time it becomes better at this distinction. Artificial neural networks are at the center of today's AI applications, whether it is ChatGPT, facial recognition, self-driving cars, or even the YouTube recommendations that you see here are AI generated. Have you ever wondered how YouTube exactly knows which videos you want to watch next and starts recommending videos one after another, wasting your life? Anyways, but how did we get here? How did we go from early days of computing to these brain-like machines? This is where the work of John Hopfield and Geoffrey Hinton is important. Let's talk about John Hopfield first. Back in 1982, he introduced what is now known as the Hopfield Network. It was an artificial neural network designed to mimic how our brains recall memories. Think about how you remember things. Suppose you are trying to recall a name of a movie you watched years ago. Now you may not be able to recall immediately, but slowly and steadily you start recalling a particular character, particular scene, or a particular song. And slowly and steadily your brain starts connecting the dots and you immediately get the name of the movie. Now this process is called associative memory and it is a key feature how we store and retrieve memory. Hopfield was fascinated by this and wondered if machines could replicate it. He used principles from physics, specifically the concept of energy minimization, which describes how systems tend to settle into low energy states. He applied this idea to neural networks, creating systems where memories could be stored as low energy configurations. Essentially, his network could store patterns like images or sequences of information and then retrieve them even if the input was incomplete or noisy. For example, if you showed the network a blurred or partially distorted image of a face, the Hopfield's network would be able to construct the image, identifying the most likely match from the patterns it had previously stored. This was a breakthrough in AI because it allowed machines not just to process the data but to recall information in the way similar to the human memory. At the time, this was revolutionary. Hoffield's work laid the foundation for many of the AI technologies we use today, particularly those involve pattern recognition such as facial recognition, image reconstruction, and more. Now let's move on to Geoffrey Hinton. He is often called the godfather of AI. Hinton built upon the Hoffield's work and took it to a whole new level. In mid 1980s, he developed what is now known as the Boltzmann Machine, a type of neural network that uses probabilistic reasoning to learn from the data. While Hopfield focused on storing and retrieving patterns, Hinton's Boltzmann machine introduced a way for machines to learn from examples. This means that instead of just recognizing patterns, the machine could analyze the complex data and even generate new patterns. But perhaps Hinton's most significant contribution is the backpropagation algorithm. Introduced in 1986, it's a method for training deep neural networks by adjusting the internal weights of the network's node after each learning cycle. This allows the machine to learn from its mistakes and improve over time. This algorithm is what makes today's deep learning systems possible. It's the reason why AI can now perform complex tasks like understanding natural language, recognizing faces in the crowd, or even generating art and music. Hinton's work didn't just advance machine learning, it made modern AI systems scalable. The deep learning models that we rely on today, from self-driving cars to natural language processing tools like ChatGPT, all trace back their roots to Hinton's breakthrough in 1980s. Now you might be wondering how these inventions and discoveries in computer science get the Nobel Prize in physics. The answer lies in how Hopfield and Hinton developed their models using the core concepts of physics. Take Hopfield's network for instance. The way the nodes interact is mathematically similar to how particles in magnetic material align themselves. The energy minimization concept he used is a direct application of physical laws to the problem of memory recall. Similarly, Hinton's Boltzmann machine uses the probabilistic approach inspired by thermodynamics and statistical mechanics. By applying these principles to artificial neural networks, they were able to create systems that could handle complex data in ways traditional computing methods couldn't. Today, AI is everywhere. Most of us are not even aware of it. In healthcare, for example, AI systems are analyzing medical images to detect diseases like cancer at much earlier stages than even before. Similarly, finance, climate prediction, entertainment, almost all sectors of economy are going through a transformation. Now let's look at the big question that's on everyone's mind. Can we achieve AGI, that is artificial general intelligence? And if we do, how could it change our world? First, let's understand what is AGI. To explain in simple words, AGI refers to machines that possess the ability to understand, learn, and apply intelligence to solve any problem just like a human being. The AI we have today is far from AGI. Now, can we actually achieve this level of intelligence in machines? Well, the opinion is divided. Some experts believe that with the rapid rise of AI and hardware that we have seen in the last 5 years, AGI could become reality within next 5 to 10 years. On the other hand, there are also those who are more skeptical. They argue that human consciousness and understanding are far more complex than we realize, and replicating that in machines might be more challenging than we think. But let's imagine we achieve AGI. How it will change everything? The simple answer would be like a cure for cancer, abundant food, and all the good stuff. But I doubt it will be that simple. There is genuine fear if an AGI becomes more intelligent than humans, it might act in ways that are unpredictable, even detrimental to humanity. This is the classic Terminator scenario. There is another big question of AI replacing humans. What happens when AGI will be able to do our jobs better and faster? Again, there are no simple answers. Either there will be new jobs or we will have some form of universal basic income. Given these potential outcomes, it is very important that we approach the development of AGI responsibly. It is not just about whether we can create AGI, but whether we should and under what guidelines. Governments, scientists, and communities worldwide need to collaborate to set regulations and ensure that AGI, if achieved, is developed with humanity's best interest at heart. So in the end, question is, can we achieve AGI? In my personal opinion, we will be able to achieve AGI and it will fundamentally change our world. But the difficult question is how and in what ways it will change our world. That's it for today. If you find this video interesting, consider subscribing my channel and stay updated.